In this session, we will explore virtual local area networks, known as VLANs, and their practical applications in Ethernet networks. VLANs allow network administrators to segment a physical network into multiple virtual networks, enhancing security and efficiency. We will discuss practical scenarios for VLAN deployment, such as isolating departments or user groups within an organization. We will also cover VLAN trunking, which optimizes network bandwidth utilization by transmitting multiple VLANs over a single link. By the end of this session, you will have a comprehensive understanding of VLANs and how they contribute to secure, efficient Ethernet networks. Ethernet operates as a broadcast network, floating frames to all devices within the same network. However, intelligent Ethernet switches help mitigate this floating effect by selecting resending frames only where they are needed. It's important to note that Ethernet is a layer 2 protocol, primarily designed for node-to-node data transport within a limited area, such as from one desk to another or to a nearby location. For long-distance data transport, other protocols like IP, Internet Protocol, are utilized. Now, let's explore a typical Ethernet network found in homes or small offices. The network setup typically involves a router that serves as the point of entry for the Internet connection. Additionally, Ethernet switches may be present on each floor, interconnected with cables. In larger offices, additional switches are employed to connect more end devices with Ethernet cables. In some scenarios, it is beneficial to have separated networks for different user groups. For example, you may want an IP telephony network that is isolated from the computer network, or a guest network for the security or practical reasons. One solution could involve duplicating all network devices, installing a second switch on each floor or room, and deploying additional cable connections. However, this approach incurs increased costs and maintenance complexities. Hopefully, there is a simple and much more efficient solution that allows for the coexistence of multiple Ethernet networks on the same physical devices, virtual LANs. VLANs enable the logical segmentation of a network, creating distinct virtual networks with their own characteristics and security policies. In this video, we will introduce VLANs and explore how they can facilitate the creation of separate Ethernet networks without the need for extensive hardware duplication. VLANs offer a cost-effective and manageable solution for achieving network isolation and efficient network management. Let's dive deeper into the world of VLANs.
In our previous video, we have discussed the Ethernet frame structure, which includes the source MAC address, destination MAC address, and Ethernet type field. Now, in the context of VLANs, we expand the frame size slightly by adding a VLAN header in front of the Ether type field. This VLAN header serves the purpose of identifying different virtual networks within the same physical infrastructure. The VLAN header consists of a set of bits beginning with 8 bits set as 100. It also includes additional bits for administrative purposes, such as a priority bit and the VLAN identity or VLAN ID. The VLAN identifier ranges from 1 to 4094, providing a wide range of VLAN ID options. So, what can we achieve with VLANs? By implementing VLANs, we can create multiple virtual LANs within the same Ethernet infrastructure. Each VLAN functions as a separate LAN, ensuring that computers and devices within one VLAN cannot communicate with those in another VLAN. This separation allows for the segregation of information and networking resources. Connection between switches can support one or multiple VLANs. When a connection carries multiple VLANs, it is commonly referred to as a trunk. Trunks enable the transmission of VLAN traffic in between switches, facilitating the communication and interaction between devices within each VLAN. Now, let's delve into the process of building VLANs and explore how to effectively configure and implement them within your network infrastructure. Let's explore the process of setting up VLANs in a network scenario. In our example, we have 3 switches and a router interconnected with devices connected to them. Initially, all devices are part of the same network without any VLAN segmentation. To implement VLANs, we introduce 2 VLANs, a home VLAN labeled as VLAN 10 and a guest VLAN labeled as VLAN 20. Our goal is to keep these VLANs separated. To achieve this, the switches need to be configured to assign specific ports to each VLAN. We represent the configuration of ports in different colors on the switches to indicate the association with the respective VLANs. The next step is to configure the interconnections between the switches. These connections are configured as trunk ports, meaning that they carry traffic for multiple VLANs. The VLAN number is included in the Ethernet frame, and configuring the trunk ports ensures the proper transmission of VLAN traffic in between the switches. Moving on to the router, there are 2 possible configurations. In some cases, advanced routers allow for configuring interconnection as a trunk, similar to the switch interconnections. This simplifies the configuration process. However, if this option is not available, an alternative is to have separated physical connections from the router to each VLAN as illustrated in the figure. Now let's understand how VLANs operate within the network and how switches manage them automatically during communication. In the first example, when a frame is sent within the network, the original frame carries the VLAN number assigned by the switch it passes through. As the frame reaches the final switch, the VLAN label is removed, meaning that the end devices are unaware of VLAN configuration that exists in between. The second example demonstrates how frames are sent to the internet using a VLAN configuration. A guest device sends a frame to its interconnected switch, which sets the VLAN ID to 20. The frame then travels to the top switch, where the VLAN tag is removed, and the frame is forwarded to the internet through the router. This transparent operation of VLANs ensures that devices and computers remain unaffected by the VLAN configuration. The switch handles all the necessary operations to maintain the separation and proper functioning of the different virtual networks.
VLANs play a crucial role not only in home networks but also in data centers. In these environments, where large devices connect thousands of customers, VLANs are essential for maintaining traffic separation. By assigning VLAN tags to each switch port and using trunk connections, peering services can be delivered over the same physical connection with different VLANs IDs. The same technique is applied when connecting different cloud providers. If necessary, the VLAN ID can be rewritten as frames pass through the edge device, ensuring seamless communication between providers. To summarize, let's recall some key facts about VLANs. Ethernet operates as a broadcast network. VLANs enable the establishment of virtual Ethernet networks on a shared physical infrastructure. VLAN IDs range from 1 to 4094, providing a wide range of possibilities. VLANs offer the flexibility to deliver multiple services over the same physical port, even in large professional switches. Understanding and implementing VLANs allows for efficient network segmentation and service delivery, whether in home networks or complex data centers environments.